We have two specimens of the same gas, P and Q. P is at a temperature of 280 whilst Q is at 350. We're told they exert the same pressure and that P has 10 to the 20 molecules per unit volume, and we're asked to find what is the number of molecules per unit volume of Q. This idea of the unit volume actually means we can set the volume to 1, just as we would do with unit mass in gravitational fields, for example. We're firmly in the realm of PV equals big N kT in this question because we're talking about the number of molecules, N. Since we know that the pressures are equal, we can rearrange this question to give us pressure equals N kT over V. There are several different approaches for how to go forward from this point. I'm going to use what you may think of as a slightly long-winded approach because I want to show the details of the method. What we're going to do is write down the right-hand side of the P equals formula and put subscripts P to show us that we're talking about specimen P. Then we're going to set that equal to the same formula but with subsets Q for specimen Q. Therefore, NPK TP over V. Remember, we don't need a subscript for K because it's a constant. So NQ K TQ over VQ. Remember, what we're after is to find NQ. Let's see if we can do any cancelling out. Well, we know that the volumes are both per unit volume, so we can cancel them out. We can also cancel out the Boltzmann's constants, and that leaves us with NPTP equals a number in Q times the temperature in Q. NQ is equal to number of molecules in P times the temperature of P divided by the temperature in Q. And when you bung in the numbers, 1 times 10 to the 20 times the temperature of 280 divided by 350. I should have written 10 to the 20 there and not 10 to the 2, of course. When you work this out, you get 0.8 times 10 to the 20. And that's the answer.